modeling and problem solving. So everything we do goes back to these addition identities. So we learned these all before, but you really got to remember these as we keep looking back to them. So this is what we're doing in this video, is graphing something that looks like this. Okay, A sine x plus B cos x. So just for an example, we could have y equals 2 sine x plus 9 cos x. And just to have a look at what something like this might look like in the calculator, let's do this. Let's do 2 sine x, 9 cos x. Now let's just change our window. Okay, 0 to 12 on the x gives me about 2 periods. Remember, 2 pi 6.28 is about 1 period. If you look at this graph, if you think about the maximum this could possibly get, this one has a maximum of 2. Okay, if we just graph that by itself, this one would have a maximum amplitude of 9. So if you combine the two, you wouldn't think you'd get any more than 11. So you might go all the way to 11. So let's just put 11 there. Alright, and have a look at what this looks like. And what do you know? It actually just looks like a regular sine or cos curve. It's not going all the way up to 11. So we're going to figure out what the amplitude of this thing is. And it doesn't, it looks almost like a cos curve. It almost looks like it starts at the top. But I think we'll see that it doesn't necessarily start right at the top. If I just change this number a little bit, I'll have to do 7 there. You see that one doesn't start right at the top, so it's a bit of an illusion. Anyway, so what we do is we're going to graph this. We're going to rewrite this as just a regular sine curve. Okay, this is just a regular sine curve. Or a cos curve. Why are those disappearing? What happened? Why are my arrows like that? Anyway, so this would be a regular sine curve, okay, with this new amplitude, okay. An amplitude, we're always going to assume our amplitude is greater than 0. And it's going to have some sort of a horizontal shift, okay, because it's not exactly a sine curve starting at 0. Okay, so it looks like we should be able to rewrite this curve just from looking at the graph as just a regular sine curve with a new amplitude and a horizontal shift, or possibly even a cos curve. We'll look at sine first. So if we rewrite it like this, okay, let's use our identity laws up here. Sine of 2 angles added together is sine x cos x. So this is going to be sine x cos of this alpha plus sine alpha cos x, which we expand, and I'm just going to put the alphas first. Sine x plus alpha sine a sine alpha cos x. Now, this here is a constant, because that alpha there, alpha is just a fixed number. Okay, these are both constants, which are going to match up, because this is, here's my equation I started with. So these letters there are going to match up with these letters here. Okay, this one is this one, this one is that one. So what we get is a cos alpha equals a, and b, a sine alpha is b. Okay, so what I can do here is actually square them all. And I'm going to write a squared plus b squared. Okay, I'm going to square both. So if I square the first one, so over here, it's going to be a squared cos squared alpha. And then my b squared is going to be this squared plus a squared sine squared alpha And if I come down here, I can factorize that. Alpha plus sine squared alpha equals a squared plus b squared. This whole thing here is equal to 1. Yeah, identity. So what I get is a squared equals, big A squared equals these two things. So a is the square root of them. Okay, so I don't actually consider the negative. Normally I would want the plus or minus of the square root, but we said a is greater than 0. So in this one we're looking at up here, that one with 2 and 9. So actually the amplitude of that is going to be less than 11. Amplitude is going to be the square root 2 squared plus 9 squared, which is square root of 13, which is not the square root of 13, it's the square root of 85, which is about 13.22. No, 9.22. That sounds better. So it's a little bit bigger than 9, but it's not nearly up to 11. Okay, a couple of other things. A sine alpha over a cos alpha. Okay, if I was to make this division using that information there, I get a over b. Now, a is cancelled. Sine alpha over cos alpha is tangent alpha equals a over b. So alpha equals the inverse tangent of a over b. So if you needed to calculate, that is the horizontal shift. So here's my next example. Express y equals 2 sine x minus 3 cos x in the form y equals capital A, okay, my constant A, cos of, in this case it's x minus alpha. Okay, so I've got an x minus, okay, a cos of a difference of two angles. Let's go back up here. And look at my cos of the difference of two angles. So it's cos x, cos y, and it's a plus sine x, sine y. Okay, so first off, we've got y equals a times cos x cos alpha plus a sine x sine alpha. Okay, and let me just swap those around because we want sine first, cos second. So I'm going to put it a sine alpha, sine x. Okay, I'll make this my constant, so I put the alpha first, and that is supposed to be an x. Plus a cos alpha cos x. Okay, and we know that this whole thing's got to equal that thing that we started with, 2 sine x minus 3 cos x. Okay, so we've got now a sine x, sine alpha, sorry, that is my 2. B cos alpha, that's my minus 3. I could do b, it's a. Okay. And using the a squared plus b squared thing, a squared sine squared alpha plus a squared cos squared alpha is going to be 2 squared plus minus 3 squared. Okay, I'm just squaring them both, adding them together. So this whole thing becomes a squared equals 13. A equals the square root of 13. Okay, let's use the other one. A sine theta, theta over b cos alpha, a sine alpha equals 2 over negative 3. Cancels. Sine over cos is tangent. Alpha is negative 2/3. alpha is inverse tangent of -2/3. Okay, now that is going to give us two quadrants to choose from. Okay, so that's what the calculator gives me. This gives me negative 3.7 degrees. Well, let's see, tangent and negative CAST, tangent negative here, and here, right? Quadrant 2, quadrant 4. Okay, so obviously this answer is quadrant 4. But it could also be quadrant 2, which would be 180. Basically, add 180 to that. Take that and add 180. And we get plus 180 equals 146.7 degrees. So how do we know which one it is? Because it can only actually be one of these. That's quadrant 2. And we just, to find out, we just go back up here, okay? Sine, positive. Cos, negative. Okay, because A is positive. So cos is negative in quadrant 2. Okay, so that's the answer. So we write this as remember y equals A. We'll write it as cos of x minus alpha. So we write it that A was square root 13. X minus 146.7 degrees. Done.